Okay, happy Monday. Solving radical equations is real easy, I promise. Okay, so what do we need to do if we want to solve a radical equation is we want to get all of your square root on one side, anything that's not a square root to the other side. So if I'm looking at square root of x plus 2 plus 4 equals 7, I'm just going to do minus 4 to both sides. So then I have square root of x plus 2 equals 7 minus 4 is 3, okay? And then I want to get rid of my square root. I want to get rid of my radical. So I'm just going to just square that, right? But if I do it to one side, I got to do it to the other side, okay? And then nice and simple, if we take the square of a square root, we're left with just what was under the radical. So x plus 2. On the other side, 3 squared is 9. And now we have a simple, just one-step equation. What's the value of x? So minus 2 from both sides. We get x equals 7. Okay? And then we always want to double check these. So like you saw, sometimes when solving, you might not satisfy the equation. So always go back, plug it back in just to double check, make sure it works. So the square root of 7 plus 2 plus 4, does that equal 7? So 7 plus 2 is 9, square root of 9 is 3. Does 3 plus 4 equal 7? Yes, it does. So that's a good answer. Okay. All right, let's come back to this one. This is kind of a weird problem. The other kind of problem you're going to see is like number 6 here, which looks kind of scary because like, oh, Alex, I got a square root on one side, I got a square root on the other side. And you say, that's easy. That's like best possible situation because all we're going to do, you're going to square one side. You're going to square the other side, right? And then all of my roots are just going to cancel out. So then we have x plus 4 equals 3x plus 6. That's baby work. You've been doing that since you were a toddler. You can answer that one. But still double check it at the end. Make sure when you get your answer, you can substitute it back into the original equation and it will all be equal, all be real answers. Okay, not too bad. All right. So what about this one here? Square root of x plus 12 equals 2 minus the square root of x. So you see we have a root on both sides, but we also have this 2 that's not a root. I know we said to put all the roots on one side, all the non-roots on the other, but we can't do that here because we have roots on either side. So what we do, like we did in our second example, is we're going to square both sides. So we want to get rid of as many roots as we can. So the left side, that's nice and easy. This is just going to be x minus 12. On the other side, this is going to be, and if you forgot your rules for squaring, are the sum of two, or the difference of two squares rather, sorry. So 2 minus square root of x times 2 minus square root of x. So 2 times 2 is 4. The inner is negative 2 times square root of x, and then the outer is also negative 2 square root of x. So that's a total of negative 4 square roots of x. And then the last term, square root of x times the square root of x, is just x. Okay. So this is what I'm left with. I'm going to simplify as much as I can. So I'm going to say minus x, and that helps out because that's going to cancel. So I have negative 12 equals 4 minus 4 square root of x. Okay, so this is looking a little better because now I just have one square root. So now I can put everything that's not a square root, move it to the other side. So I'm going to do minus 4, minus 4. I'm going to run out of room. That's okay. So negative 16 equals negative 4 square root of x. Now I want to get rid of the root again. So same as before. Just square both sides. This is also going to help. It's going to get rid of our negatives here. So 16 squared is 256. And then negative 4 squared is 16. Square root of x squared is just x. So I have 256 equals 16x. Divide both sides by 16. And we get x equals 16. Okay. So then I need to check my work. So I'm gonna come back over here. So if I put that into my equation, so x plus, or the square root of x plus 12, not plus 12, sorry, minus 12 equals 2 minus the square root of x. So that would be 16 minus 12 is 4. The square root of 4 is 2. Right? So I just took this 16, substituted back in the original equation. And then we have 2 minus the square root of 16, which is 4. And is this true? Does 2 equal 2 minus 4? Well, we'd end up with 2 equals negative 2, which is not true. So we did all of this work, right, to get an answer that doesn't actually fit the original equation. So we would say this one has no solution. Sad face. Okay? I don't want to say with a certainty, but from my limited experience working with these equations, the ones that are no solution generally follow this format, where you have a root on one side, you've got a root on the other side, and then just a constant just sort of hanging out. That really messes up with your ability to solve. Okay, one last thing before we let you go. I'll put this up here just to prove or to explain better why this doesn't have a solution. So what I did is I graphed square root of x minus 12. That was the left side of the equation. And we get this part of our square root. And then we graph 2 minus the square root of x. That gives us this blue line here. And we can see at no point do these two lines intersect, right? And if there was a solution, it would be the x value where the equations, where they overlap. So since they don't overlap, there can't be a solution. And that's why, or another reason why, the answer to the last example was no solution. Okay, usually they're not that hard though. So try them out. Hopefully you realize, be like, oh, this isn't so bad. This is a lot easier than dividing radicals. Why are you wasting all this time talking? And I'll be like, okay, I'll stop